Okay, this is 4.3, solving systems of inequalities. But before we get into that, let's go ahead and review graphing linear inequalities. So let's look at this first example. We have 2y plus 3x is less than 4. So the first thing we want to do is get this into slope-intercept form, or solve for y, in other words. So what I want to do is go ahead and subtract 3x on both sides. Cancels out on the left side, and I'm left with 2y is less than negative 3x plus 4. And now I want the coefficient in front of y equal to 1, so I go ahead and divide by 2. And I'm left with y is less than negative 3 over 2x plus 2. Okay, now I can graph this out just like I would a normal line. Start with the y-intercept of positive 2 and follow my slope, which is negative 3 over 2. So I'm going to go down 3 over 2. There's my next point. And now I can go ahead and graph this out. So the first thing I want to determine is whether or not this is going to be a solid or a dashed line. And because there is no line underneath this, this is just y is less than. So it is not including this line, so we are going to make this a dashed line. All right, and because y is less than the inequality on the right, we go ahead and we shade below the line. And that's it. So let's go ahead and summarize this. So when we're graphing inequalities, basically what I have here, these two will determine how you shade, and these two will kind of tell you how or whether to use a solid or dashed line. Okay, so the first one here we have y is greater than or equal to, and so our translation is saying y is bigger or bigger than the inequality statement on the right. And so if you have these two symbols, okay, you're going to shade above. All right, if y is smaller than that, right, if we have these two symbols, less than or equal to, then we're going to shade below. Okay, it's as easy as that. And the next part, so if we have the line underneath, right, because we have these lines underneath, those mean that the line is included, right? So y is also equal to, the line is included. So that's when we use a solid line. If we don't have those lines underneath, like these two examples here, right? If they're just less than or greater than, we're going to use a dotted line, okay? So hopefully this little graphic helps you. If you do need more help with this, you can watch some of the videos I have for Algebra 1. I'll go ahead and link them on the Google Classroom Google Doc. Okay, now that we've reviewed graphing inequalities, now let's look at solving systems of inequalities. So let's look at example 2 here. We have the first inequality is just y is greater than or equal to -1. So that is going to look like this. It's going to be a horizontal line passing through -1 on the y-axis. And we're going to shade above because we have a greater than symbol. I'm going to hold off on shading here because it's a little tough with this online pen here. Okay, and then the second inequality, I want to get into slope-intercept form. So I'm going to add an x on both sides. And I'm left with -2y is less than x minus 4. And now I divide by -2 on both sides. And I'm left with y is greater than, we need to switch our signs here because we're dividing by a negative to solve. On the right side, I have 1x divided by negative 2. That's the same as negative 1 over 2, and then put the x off to the side. And negative 4 divided by negative 2 is positive 2. Okay, let's go ahead and jot this down in case you forgot here. Little reminder here, flip the sign when you multiply or divide by a negative to solve an inequality. Okay, pause the video if you need to. All right, so now let's go ahead and graph the second inequality out. Let's start at the y-intercept of positive 2. You know what, I'm going to go ahead and pick a different color here. I'm going to start at positive 2, and my slope is negative 1/2. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. All right, so now let's determine, is this line going to be solid or dashed? There is no line underneath the greater than symbol, so this does not include the line. So we're going to make this a dashed line. Okay, and it is greater than, so we shade above. All right, so I'm going to shade up here. This is much easier with pencil, so bear with me with this online marker. Okay, and let's go ahead and graph this one out as well. So y is greater than or equal to -1. That would be greater than is to shade above. So that's going to be everything here. And so what we're looking for, the solution, is the double shaded area. Okay, so hopefully we can recognize that would be, I'm going to use another, that would be like this green triangle here. It doesn't stop, but I just want to show you that that's like the double shaded area. That's the solution. And obviously that's going to keep going off here as well, but I just want to show you that that's the solution to the inequality. Okay, so let's go ahead and jot that down. The solution to an inequality is where the shadings overlap. All right, let's try another one. This one's a little bit more intense. We gotta solve or put them both into slope-intercept form. So let's start with the top one. I'm gonna subtract 2x on both sides. So I'm left with 4y is greater than or equal to -2x minus 8, and divide by 4. And I'm left with y is greater than or equal to -1/2 x minus 2. Now I'm going to use a different color for the bottom inequality. I'm going to do the same thing, subtract 2x on both sides. So I'm left with 4y is less than or equal to -2x plus 12, and divide by 4. And I'm left with y is less than or equal to -1/2 x plus 3. All right, so there's our two inequalities. Let's go ahead and graph them out. Let's start with this blue one here, okay? So y is less than or equal to -1/2 x plus 3. Let's start with the y-intercept of 3. So that's right there. And we're going to go down 1 over 2, down 1 over 2. And we're going to determine if the line is solid or dashed. It is going to be solid because we have the line underneath. So let's connect these points with a line. And now we determine if we're going to shade below or above. It is y is less than, so we shade below. Okay, so I'm going to go ahead and shade below. Okay, now I'm going to use my red marker and graph this one out. Y is greater than or equal to -1/2 x minus 2. So for this one, I'm going to start with the y-intercept of -2. and my slope is -1/2. So I'm going to go up 1 over 2, up 1, back 2, up 1, back 2. I can also go in the other direction, right? I can go down 1 over 2, and that's on the same line. Determine if it's solid or dashed. It is going to be solid because we have the line underneath. So let's connect these points with a solid line. And we are going to shade above because this is greater than, so we shade above. So that means this part here is going to be going this way. And so hopefully we're recognizing that the solution is this overlapped section right in the middle here. Moving on. Let's try another example here. These ones look a little bit easier to solve. First one, we can write this in slope-intercept form by simply subtracting x on both sides. So I'm left with y is greater than -x plus 3. And the second one, I just need to subtract 2 on both sides. So change my colors. Got y is greater than, less than -x minus 2. And now let's go ahead and graph these out. Start with the top one, y is greater than -x plus 3. Start with the y-intercept of 3. It's here. And we have a slope of -1. So it's going to be going down 1 over 1, down 1 over 1. All right, and is it going to be a dashed or solid line? It is going to be dashed because it is not equal to. The line is not underneath the symbol, so this is going to be a dashed line. And we are going to shade above because it is a greater than symbol. So this is going to go this way. And now let's switch over to my blue pen. And let's graph out the second equation. Y is less than -x minus 2. So let's start with the y-intercept of -2. And we have the same slope of -1. So that's going to be down 1 over 1 or up 1, back 1. And again, we're going to have a dashed line. All right, and we are going to shade below because this is y is less than, so we shade below. And so our solution is where these overlap and they don't overlap, so there is no solution to this system of inequalities. Okay? All right, example 5. Switch back over. First one's already set for us. X is greater than or equal to 0. Okay, well, that is just going to be a solid line. That's basically going to be our y-axis. All right, now let's do the bottom equation. Go ahead and subtract 5x on both sides. And I'm left with -2y is less than -5x plus 4. And divide by -2, divide by -2, divide by -2. I'm left with y is, switch the sign, don't forget that, 5 over 2 positive. Remember, we're going to keep this a fraction, but if we have a negative over a negative, we have to recognize that the fraction is positive. And positive 4 divided by -2 is -2. All right, so now we can go ahead and plot this out. Start with the y-intercept of -2. And we have a slope of 5 over 2. So let's go up 1, 2, 3, 4, 5 over 2. That's right there. Again, we're going to have a dashed line because we don't have the line underneath here. So let's connect these 2 points with a dashed line. And now let's determine our shading for both of these. So let's start with the blue one because I already have my blue pen out. So y is greater than this, so we're going to shade above. This is going to be going this way here. And we should shade out our top inequality. X is greater than or equal to 0. So that is going to be greater than, in terms of the x, greater is going to be to the right, right? Greater numbers are to the right on the x-axis, right? Like this would be 1, 2. This is positive 3 over here. This is negative 2. So the bigger numbers are to the right. So for this one, we're going to shade over here. And so where is the overlap? It looks like it's right in here. There's the sweet spot. And there we go. There's your solution. We got one more. Is the 0.23 a solution to number 5? Let's take a look. 2, 3. Let's get out black pen here. Get a little bit smaller. 2, 3. So go over 2, up 3. That is right here. And that is on the dotted line. So no, it is not a solution because it's on the dotted line. All right, that's all I got for you guys. Give these practice problems a shot. If you need help, you know where to find me. Good luck.